All right, so these are the notes to review for the test on Monday and Tuesday. So the first thing I want to look at is what we mean by the domain, the invertible domain of the unit circle, or the invertible domain of each trig function. So think of the trig functions like islands. And on each island, there's a nice green, safe area where you can go and roam around and do whatever you want to do. But then there's this like dangerous lava-infested area with like things that are going to try to eat you and stuff. And you can't go over there. Under no circumstances can you go over there. Cosine Island has a similar area, and so does Tangent Island. Okay, we don't go over there. We only stay in the green part. So on Sine Island, we can go right along the edge of Sine Island, like right up to the cliff of Sine Island. Cosine Island, we can do the same thing. We can go right up to the cliff. Like there's a nice safe cliff that separates you from all the stuff that wants to eat you. And as long as you don't go over that island, you're fine. So on Sine Island, we can stay between negative pi over 2 in the south and pi over 2 in the north. Now we have to say it that way. We can't just say, oh, 270, because to get to 270 or to get to 3 pi over 2, you have to go through the area where things want to eat you and kill you. We can't have that. So if you're starting out here, to get anywhere down here, you can't go around the circle. You can only go in the negative direction. You can only go south. The same thing with Cosine Island. Also over here on Sine Island, we could say negative 90 to 90 also. And notice the brackets tell us we can go right up to the edge. We can be on the edge. We just can't go over it. Cosine, our restrictions are from 0 to pi, or from 0 degrees to 180 degrees. So we can, and again here, we can go right up to the edge. We can stand on the edge. So we go 0 to pi, or we can go 0 to 180. Tangent's a little different. On Tangent Island, there's not a nice safe cliff. There's like a rickety wooden fence that if you touch the fence, things are going to poke their claws through and they're going to pull you through the fence. So we can get right up to the fence, but we can't touch the fence. That fence exists, much like the barrier in sine, exists at negative pi over 2 to pi over 2. So again, to get anywhere over here, we can't go through this area because things will eat us. We have to go this way. So we might have to go into the positive, or we might have to go down into the negative. So this would be 90 degrees and negative 90 degrees. So the other thing that we can say here is that we can go from negative pi over 2 to pi over 2, or from negative 90 to 90. But what we can't do is touch the barrier. So we get parentheses to tell us don't touch the barrier. It's not safe. This has a nice sturdy bracket, nice good barrier like the cliff. This does not. This is a weak barrier. All right, so we're going to use this information to answer a few questions. So we're going to use the unit circle to find the exact values of the following function, or the following expressions in degrees and in radians. So the first thing is the inverse cosine of negative 1. So what this is asking me, another way to say this is, what angle has a cosine of negative 1? Now cosine is the x coordinate on the unit circle. So we could actually change cosine to x. What angle has an x of negative 1? So now for cosine, I want to stay in the top portion of my island. So I'm going to go over to my unit circle and I'm going to look just in the top portion for the angle that has a x coordinate of -1. Well, that's over here at 180. So pi or 180. So pi radians or 180 degrees. Now, what about the inverse sine of negative square root of 2 over 2? So what we're asking is what angle has a sine of negative square root of 2 over 2. But sine equals the y coordinate. So we could also say what angle has a y of negative square root of 2 over 2. For sine, we want to stay over here on the right-hand side. So let's go take a look at our unit circle. On the right-hand side, I'm going to fold it in half so we're not even tempted to look at the other side. On the right-hand side, we're looking for a y coordinate of negative square root of 2 over 2. So that's down here at 315 or 7 pi over 4. The problem is those angle measurements are based on going around the unit circle, and we can't go over here. So we have to find another way. So we have to back up. We have to go in the negative direction. So to get down here to 315 or 7 pi over 4, I'm going to subtract from 360. I'm going to say, all right, I went down negative 45 degrees or negative pi over 4. So negative 45 degrees or negative pi over 4 radians. All right, so now go ahead and pause and then make an attempt to work out these 4 questions, and then we'll come back. All right, so for 1A, you should have gotten 180 or pi. For 1B, 135 or 3 pi over 4. 1C, 90 degrees or pi over 2. And then for D, I wanted to look at that one because first of all, there's no decimals on your unit circle. So you have to remember that 0.5 is the same as 1/2. So what we're really asking is what angle has a y coordinate of negative 1/2. Well, this is sine, so I want to go into my right side of the unit circle. And here is my angle that has a y coordinate of negative 1/2. So that is 330 or 11 pi over 6. I can't get there because those are based on going around this way. I have to go this way because I can't go through the lava. So to get down here, I have to go negative 30 degrees or negative pi over 6 because this would be 12 pi over 6. So I go negative pi over 6 or negative 30 degrees. All right, so question number 2. I'm still looking for the inverse, but then after I find the angle, I'm going to do something else to it. So here I've got the inverse cosine of 0. So first thing I'm going to do is figure out what's the inverse cosine of 0. So cosine is the top portion of my unit circle. So I want to know which angle has an x value of 0. So that's pi over 2 or 90 degrees. It doesn't matter whether we do radians or degrees because we're just going to go back and get the sine of it. So I'm going to rewrite this. This is another way of saying what is sine of 90 degrees because this is 90 degrees. Okay, so now sine of 90 degrees, that means what is the y coordinate of 90 degrees? Well, the y coordinate of 90 degrees is 1. So that's the answer to that one. The inverse cosine, the sine of the inverse cosine of 0 is the same as the sine of 90, which is equal to 1. Now, tangent of inverse sine of negative square root of 3 over 2. So I got to first find out inverse sine of negative square root of 3 over 2. I'm going to look at my right side of the circle for negative square root of 3 over 2, and that's right here. Now, because I'm just going to use the coordinate, it doesn't matter about the angle. So I'm going to just use 300 just because we care about the location, but not so much how you got there or anything. So this is another way of saying what's the tangent of 300. Now to get the tangent, I'm going to take y divided by x. So let's write that up here. Tangent equals y over x. So the y coordinate here is negative square root of 3 over 2. And I'm going to divide that by the x coordinate, which is 1/2. Except we know that we can't do that. So I've got to bring this up and make it multiplication. So negative square root of 3 over 2, or times 2 over 2 times 1. So I can get rid of my 2's, and I end up with negative square root of 3 over 1. So that means that this is just negative square root of 3. All right, so go ahead and pause and work out A, B, C, and D. All right, so I went ahead and grabbed these right off the unit circle. The inverse sine of square root of 2 over 2 gives me 45. So I'm looking for the cosine of 45 degrees. The cosine of 45 degrees would be the x coordinate, so that is square root of 2 over 2. The inverse cosine of negative square root of 3 over 2 gives me sine 150. Now it doesn't really matter that it's in the wrong quadrant for sine because it's inverse cosine. So the cosine is where the 150 is, and then you can take the sine of 150. You just can't do the inverse sine and get 150. So the sine of 150 is the y coordinate at 150 degrees, so that's 1/2. This tangent was a lot easier than the one I did. The inverse sine of 0 is just 0. So the tangent of 0 is going to be, those two coordinates are 0 and 1, so 0 divided by 1 is just 0. And then the inverse sine of 0.5 is the inverse sine of 1/2, so that is 30 degrees. The cosine then of 30 degrees is the square root of 3 over 2. All right, so question number 3, we actually use this concept every time we solve a trig function. That is that the original undoes the inverse and the inverse undoes the original. So when you have an original and an inverse next to each other like that, all you're left is what's inside the parentheses. So the same thing over here, even though the inverse is on the outside, the inverse tangent of tangent is like saying plus 2 minus 2. You're right back where you started. So 7/8. So go ahead and take like 30 seconds and knock out these last 4 problems. All right, so what you should have gotten is 13 pi over 8, because that's just what's inside the parentheses, square root of 7, 4 over 9, and 0.583. Okay, so for question 4, these graphs kind of represent the same thing that the circles represented. So the invertible domain of sine was this half of the sine circle, or the circle, from negative pi over 2 to pi over 2. This graph also goes from negative pi over 2 to pi over 2. Same thing with cosine, we go from 0 to pi, and tangent has asymptotes that we can't see, but they're there at negative pi over 2 and pi over 2. So it approaches those two things, but never actually reaches them. So we're going to remember a couple of concepts, is that the domain and range, when you go from the original, so the domain of the original becomes the range of the inverse. And in turn, the range of the original becomes the domain of the inverse. So if we're asked over what domain is the graph of y equals cosine x invertible, we're looking at the graph of cosine x and just looking at the invertible domain. So 0 to pi would be the answer to that question. And it does include the endpoints. We can tell by the dots on the ends. Now, what is the range of arctangent? Well, arctangent is another way of saying inverse tangent. So the range would be the domain of tangent. So the domain of tangent is the range of arctangent or range of inverse tangent. So the domain goes from negative pi over 2 to pi over 2, not including negative pi over 2 or pi over 2. So it would be negative pi over 2 to pi over 2 inside parentheses, not brackets. So go ahead and try these 4 and we'll come back and look at the answers. All right, so the range of arc cosine is going to be the domain of sine. The domain of sine is negative pi over 2 to pi over 2 in brackets because it can be equal to negative pi over 2 and pi over 2. The next question, asking a similar thing. Over what domain is y equals tangent x invertible? So this is basically asking the same question as what is the range of arctangent is over what domain is tangent invertible? Well, tangent is invertible from negative pi over 2 to pi over 2, not including the endpoints. What is the domain of arc cosine? So in other words, we're asking what is the range of cosine? So cosine, without having anything applied to it, just the regular parent function y equals cosine x, goes from negative 1 to 1. So that includes brackets because it is equal to both of those things, negative 1 and 1. And then I ask you this question just to see if you were paying attention. I really did do that on purpose. What is the range of arctangent? We already did range of arctangent up there. Just wanted to make sure that you were paying attention because many of these questions that are on your notes also end up in your test. So we can't just do something and then forget that we did it. Sometimes it comes back around. All right, so question number 5. F of t is a sine function with a period of 3 pi. What is the frequency, or b, of f of t? So we're given the period, we want the frequency. So because it's a sine function, period equals 2 pi over b. We're given the period of 3 pi, so 3 pi equals 2 pi over b. I can add a 1 under here so that we can cross multiply. So I get that 3 pi b equals 2 pi. So then I'm going to divide both sides by 3 pi to get b all by itself. My pi's cancel out over here, and b equals 2/3. All right, g of t is a cosine function with a frequency, or b, of 3 pi over 5. What is the period of g of t? So this time I have the frequency. It is a cosine function. So period equals 2 pi over b. I don't know the period, but I would like to get it. So I'm going to take my b, or my frequency, of 3 pi over 5, and I'm going to do 2 pi divided by 3 pi over 5. Now I can't divide like that, so what I have to do is do 2 pi times 5 over 3 pi. My pi's cancel out, and I get 10/3 as my period. All right, so take a minute and do A, B, C, and D, and then come back and check your answers. All right, so for 5A, what is the period of a sine function whose frequency is 7? I start out with the same equation, period equals 2 pi over b. So I set up my equation, p equals 2 pi over 7, and I can't do anything else with that fraction, so the period is just 2 pi over 7. 5b, I start out with the same equation, p equals 2 pi over b. That gives me 2 pi over 3 pi over 8. I can't do all that multiplication or division of fractions. So what I have to do is multiply by the reciprocal. So I get 2 pi times 8. That's a mistake next to the 8. 2 pi times 8 over 3 pi. My pi's on the top and bottom cancel out. And so I'm left with 2 times 8, which is 16 over 3. So 16 thirds. Let me white out that thing so that, there we go. It's like it never happened. All right, 5C. What is the frequency of a sine function with a period of 5? So period, I did away with the equation, so I had a little bit more room. Same equation, P equals 2 pi over B. P is 5, 2 pi over B. I put a 1 underneath the 5 so I could cross multiply. I get 5B equals 2 pi. I then divide both sides by 5 and I get a a frequency of 2 pi over 5. And then what is the frequency of a cosine function with a period of 7 pi? I set up my same equation, P equals 2 pi over B, so 7 pi equals 2 pi over B. I put a 1 under the 7 pi so I can cross multiply. I get 7 pi B equals 2 pi. I divide both sides by 7 pi. The pi's cancel out, and I get a frequency of 2/7. Right, so question number 6, what are the horizontal and vertical shifts of the function -2 sine 5x minus 7 plus 2? So in order to deal with the horizontal shift, I have to divide the 5 out of these parentheses. All I care about is getting the x by itself, so I'm going to divide out whatever is preventing the x from being by itself, and that leaves, in this case, minus 7/5, which isn't pretty, but it's accurate. So now I can look at this and I see that my vertical shift is outside the parentheses. So my vertical shift is going to be up 2 units. Outside the parentheses, it goes in the same direction of the units, so up 2. My horizontal shift, also known as phase shift, is inside the parentheses and we go in the opposite direction of the sign. So this is minus 7/5, so we're going to go to the right 7/5. So 7/5 right. So vertical shift is outside in the same direction as the sign. Horizontal or phase shift is inside, opposite direction of the sign. Go ahead and work out these other 4. All right, so in 6a, we divide out a 2, we get 2 times x minus 4 instead of 2x minus 8. The horizontal shift would be 4 to the right, the vertical shift is 5 up. 6b, we divide out 3, that leaves us with 3 times x plus 5/3. Horizontal shift or phase shift would be 5/3 to the left, vertical shift is 9 down. Here we divide out 5 pi, so that leaves us x, and then 2 pi divided by 5 pi is 2/5, because the pi's on the top and bottom cancel out. So we have a horizontal shift of 2/5 left because it's plus, and a vertical shift of 1 up. And then D, we divide out 2 pi, that leaves us with x for the first term, and then 6 pi divided by 2 pi, the pi's cancel out and we're left with 3. So my horizontal shift is 3 to the right because this was negative, and my vertical shift is 7 down. All right, so number 7 says write the equation of the midline for each function. So my midline is directly tied to my vertical shift because my midline for a sine function is normally y equals 0. So this would be a sine function, not necessarily the sine function, but this would be a sine function with the midline at 0. If we shift down 1, 2, 3 spaces, that shifts my midline down 3 spaces to y equals -3. So the midline would be y equals -3. The same thing happens here. If I shift cosine up 2 units, the midline is now at y equals 2. So go ahead and do 7a, b, c, and d and come back and check your answers. All right, so I have my vertical shift is +6, so my midline is at the line y equals +6. In 7b, my vertical shift is down 3.2, so my midline is at y equals -3.2. For 7c, my vertical shift is down 3.45, so my midline is at y equals -3.45. And for 7d, My shift is 14 units up, so I am at a midline of y equals 14. All right, so we want to look at the amplitude of each function. So the amplitude is the distance, half the distance from the top to the bottom. So we're going to do top minus bottom, otherwise known as maximum minus minimum, divided by 2. And if you use this all the time, instead of trying to like just kind of use your eyes to figure it out, you'll get it every single time. So the top of this function is at 6, the maximum, the bottom is at 0. So I'm going to do 6 minus 0 divided by 2. That is 6 over 2, which equals 3. So the amplitude is 3. Over here, I have a little bit of a shift happening, which can throw off your eyes if you're just looking for the amplitude, but we don't need to do that. I can go up here to 3, down here to -1. I'm going to do top minus bottom, so 3 minus -1. Don't be taking shortcuts with your positives and negatives. And what I get is 3 minus -1 is 4 over 2, which equals 2. So my amplitude is 2. Notice that these are always coming out negative. Or positive, I'm sorry. Positive. They're not coming out negative. All right, so go ahead and do your 4, and we'll come back and check the answers. All right, so for 8a, you should have gotten 2 minus -6 over 2. 2 minus -6 is 8. 8 divided by 2 is 4. For 8b, 0 minus -4 is 4 divided by 2 is 2. For 8c, 2 minus -4 divided by 2 is 6 divided by 2, which is 3. And then for 8d, 6 minus 2 is 4. 4 divided by 2 is 2. So notice, again, all the amplitudes are positive because you're doing the top minus the bottom.